Hi students, welcome to Sankalp Learning Classes. In this session, we'll be dealing with the 2-mark questions of the chapter Inverse Trigonometric Functions. We have already discussed the 1-mark questions and we'll be moving on to the questions today because we have already discussed the important points that are needed to solve the problems in the previous session. Alright, so before moving on to today's session, I'll be discussing 1-mark questions from this chapter. I have forgotten to mention the graph questions from this chapter in the previous session. So we'll just have a quick um, uh, we'll just move on to the 1-mark questions first. Then we'll deal with the 2-mark questions. All right. So this is our first question. So you can see a graph in the slide. That is, the question is identify the function from the above graph. All right. You have to observe the graph and you have to identify the particular function. All right. So how will you identify a function from a given graph? You have to analyze the domain as well as the range of the function, right? So what is the domain here? You can just a minute. Now it's a little more bigger. So now can you identify the domain of this graph? What is the domain? Domain means nothing but the set of all x values, right? Set of all x values is the domain of a particular function, right? So here you can see, here you can clearly see the x-axis here, right? This is the x-axis, which means this will give you the set of all x values, right? So this graph extends from, you can see that this is going like this, right? That means it is starting from here and it is going like this. So which all values are covered here? Which all x values are covered here? It is covered from -1 to 1, right? You can see that -1 to 1 is the domain of this particular graph. And what is the range of this graph? What is the range of this graph? Here you can see that the graph is going like this, right? Which means till this portion from minus pi by 2 to pi by 2. Minus pi by 2 to pi by 2. The values, y values are extending from minus pi by 2 to pi by 2. X values -1 to 1 and y values is minus pi by 2 to pi by 2, which is the graph. You have already studied the domain and ranges of inverse trigonometric functions, right? So which one will be the function given in the graph? It is nothing but sine inverse, right? Sine inverse, we know the sine inverse, the function sine inverse of x or sine inverse. From where to where it is defined, the sine inverse is defined from, the minus closed interval -1 to 1 to closed interval minus pi by 2 comma pi by 2. Here you can see that pi by 2 and minus pi by 2 are included because there is no imaginary lines over there in minus pi by 2 and pi by 2. So we can clearly say that minus pi by 2 and pi by 2 are included. So it is closed bracket. So which is the graph here, which is the graph shown here. It is nothing but sine inverse of x. All right. Now, one more question for the 1-mark question. Okay. Identify the domain from the following graph. That is, you have given a graph. You have to identify the domain of the graph. Okay, domain means, first of all, you have to be very clear about the concept domain and range. Domain means the set of all x values and range means the set of all y values. So here you have asked about the domain of the graph. So which values you should check? You should check the x values. And what is x values? X values is nothing but that is shown in the x-axis, right? Here you can see that the graph is extending from here to here. That is, it is going beyond all these values, right? -10 and 10, they have just marked, but it is going from here to here, right? Okay, so it is starting, the starting point is, it is -10 and then the end point is 10. So what will be the domain of the following graph? It is starting from here, -10 also has an image, and similarly all the points in between -10 and 0 has an image. Then from 0 to 10 also you can say that every element has an image, right? So from -10 to 10, this graph has image and it extends in between minus pi by 2 and pi by 2. Okay, it extends in between. Here you can see that minus pi by 2 and pi by 2 are marked, but they are marked in an imaginary line. Okay, they are marked in an imaginary line, which means minus pi by 2 and pi by 2 are not included. Okay, minus pi by 2 and pi by 2 are not included. That's why they have given a imaginary line over there. But here they haven't asked about the range of the graph. Then only you have to consider these minus pi by 2 and pi by 2. Here they have only asked about the domain of the following graph. So what will be the domain of this following graph? It is closed interval minus 10 to 10. Right? Closed interval minus 10 to 10. Okay. So I hope this is clear to you all. Now we are moving on to today's session. That is nothing but the 2-mark question. Okay. So straight away we are going to discuss the question. All right. So the first question is, the principal value. Find the principal value of cos inverse of cos 7 pi by 6. All right. You have to find out the principal value of cos inverse of cos 7 pi by 6. Right. So we know the property cos inverse of cos x is equal to x. Right. Cos inverse of cos x is equal to x. Only if that x belongs to the principal value branch of cos inverse, right? What is the range of cos inverse? It is nothing but closed interval 0 pi, right? Closed interval 0 pi is the range of the function cos inverse. So that x should belongs to the closed interval 0 pi, right? So here if you have to apply that property, we know that 7 pi by 6 should belongs to that interval. Okay, if you want to write cos inverse of cos x is cos 7 pi by 6 is equal to 7 pi by 6, then 7 pi by 6 should belongs to, if it is 7 pi by 6, then this 7 pi by 6 should belong to this interval, right? So let's check whether it belongs to that interval. 7 pi by 6 means 7 into 180 by 6, right? That is 7 into 3, that is equal to 30, that is equal to 210 degree. 210 degree doesn't belongs to closed interval 0 pi. 0 pi means it only extends up to 180, right? Pi means 180. 210 is beyond 180. So we can say that 210 doesn't belongs to that particular. Okay, 210 doesn't belongs to closed interval 0 pi, right? So what you have to do, you have to find out the equivalent angle of 7 pi by 6 that belongs to this particular range, okay, or the principal value branch of cos inverse. So how will you find out the equivalent angle of 7 pi by 6? You have to apply the reduction formula, right? So how will you write this cos 7 pi by 6? Cos inverse of cos 7 pi by 6. Okay. So, I'll start just with the cos 7 pi by 6, otherwise you'll get confused. So, here I'm considering only this portion of 7 pi by 6. So, we are going to apply the reduction formula. Okay, so why you are applying reduction formula? In order to find out the equivalent angle of 7 pi by 6 that belongs to the principal value branch. All right. So, how will you do that? You have to either convert it into some minus pi by theta, pi minus theta, or some 2 pi minus theta, right? Then only the cos value will become positive. So these are all the concepts that you have studied in the chapter trigonometry, and it is all very important in order to solve these type of problems. All right. So here you know that again I have already discussed in the last classes and all. Here every function, every trigonometry functions are positive. Here only sine and its reciprocal cosec are positive, and here we know tan and its reciprocal cot are positive, and here we know that cos and then its reciprocal sec. Okay, reciprocal sec are positive. So here it is cos 7 pi by 6, and we need positive angle, right? So which quadrant we should choose? Which quadrant we should choose? Can we take this quadrant? We can't take this quadrant because here we know cos is negative, right? So here in the question you can say that it is a positive quantity, so we can't take that one. And can we take this one? Here also cos is negative, right? Now here only cos is positive. So what is the angle representation of that quadrant? That is the fourth quadrant, right? So what is the general form of the angles in that quadrant? It is nothing but 2 pi minus theta, right? 2 pi minus theta is the general form of the angles in the fourth quadrant. So how will you convert this into 2 pi minus theta? We can change this as cos of 12 pi minus 5 pi. What is 12 pi minus 5 pi? It is 7 pi, right? By 6. Okay. Okay. Then you will get here, if I cancel this 6 with 12, okay, if I cancel the 6 with 12, then this will become cos of 2 pi minus 5 pi by 6. Alright, 2 pi minus 5 pi by 6. Okay, now we have changed the 7 pi by 6 into such a form that that angle belongs to the fourth quadrant. Okay, 7 pi by 6 is written as 2 pi minus 5 pi by 6, so that it becomes an angle in the fourth quadrant, and in that particular quadrant we know that cos is positive. All right, so it can be written as cos of 2 pi minus 5 pi by 6. Now what we have to do? We have to apply the property. What is the property? Cos inverse of cos of 7 pi by 6. And now I'm going to write it like this. Okay, cos of 2 pi minus 5 pi by 6. Okay, so cos inverse of cos x is equal to x. So this will become 2 pi minus 5 pi by 6. I'm sorry, this is equal to, the value is, we have to write the value also. What is cos of 2 pi minus 5 pi by 6? It is cos of 5 pi by 6, right? Cos of 5 pi by 6. So the value here is cos of 5 pi by 6. Right? We know the property cos of 2 pi minus theta is equal to cos theta. Here in place of theta it is 5 pi by 6. So cos of 2 pi minus 5 pi by 6 is equal to cos 5 pi by 6. These are all properties of trigonometric function. All right. So we have got the answer. Now this 2 pi minus 5 pi by 6, how I can write? Cos inverse of cos of 5 pi by 6. Okay. Cos inverse of cos of 5 pi by 6. All right. So what is the answer? What is the answer? Cos inverse of cos of 5 pi by 6. We can apply the property cos inverse of cos x is equal to x, right? So that is equal to 5 pi by 6. Okay, cos inverse of cos of 5 pi by 6 is equal to 5 pi by 6. And we have to check whether this 5 pi by 6 belongs to the principal value branch, whether it belongs to, how will you check? 5 into 180 by 6, right? So this will get cancelled. So this is equal to 30. So that is equal to 150 degree. And what is the principal value branch? It is nothing but closed interval 0 pi. That is 150 belongs to closed interval 0 pi. So we can definitely say that 5 pi by 6 belongs to closed interval 0 pi. So the answer is nothing but 5 pi by 6. All right, 5 pi by 6 is the answer. Now we are moving on to the second question. Okay, so the second question is find the principal value of, find the principal value of, find the principal value of sec inverse of minus 2. Okay, find the principal value of sec inverse of minus 2. How will you find out the principal value? First of all, you have to change the, we have to apply the property, right? Which property you have to apply in order to find these type of answer? That is, we have to apply sec inverse of sec x is equal to x. All right, this is a property that you have to apply. So how will you convert the question into this property? We have to find out the corresponding value of the function sec that will give you the value 2. Okay, you have to find out the corresponding value of the function sec that will give you the value 2. That is, you have to replace this 2 with some function of x, sec x. Okay, some sec x. So how will you find out that angle? That means you have to find out which value of x will give you 2 for the function sec x is equal to 2. You don't know the standard values of sec. So you just think about its reciprocal. What is its reciprocal of sec function? It is nothing but cos. So you take the reciprocal 1 by sec x is equal to 1 by 2. What is 1 by sec x? It is nothing but cos x. Cos x is equal to 1 by 2. So which value of angle or which value of x for the function cos will give you 1 by 2? Cos pi by 3, right? Cos 60 is 1 by 2. Isn't it? Cos 60 is 1 by 2. So cos pi by 3 is 1 by 2. So what about sec pi by 3? It's reciprocal, right? So sec pi by 3 is nothing but 2. Alright, cos pi by 3, 1 by 2. So sec pi by 3 is 2. Now we have got the x value. So how can you rewrite this one? Sec inverse of minus 2. Sec inverse of minus 2 can be written as sec inverse of minus sec pi by 3. Alright, minus sec pi by 3. Okay, now we cannot apply the property sec of minus x is equal to minus sec x because cos and sec does not satisfy that property. Sine, its reciprocal cosec, tan and its reciprocal cot satisfies the property. That is, you can take the minus outside to the angle value. Here you can say that minus is outside of the sec value. We can't take that minus to the pi to inside, that is to the angle side, that is pi by 3. Okay, so we have to again apply the reduction formula in order to convert this into a positive quantity. Okay, so how will you do that? If this was if this was sine pi by 3, okay, minus of sine pi by 3, then we can convert this one as sine of minus pi by 3. We can take the minus 2 inside. Here we cannot do that. For cos and sec we cannot apply that property because even if there is a minus side, then it will be positive. That is sec of minus pi by 3 is sec pi by 3 itself. It is a positive quantity. Okay, minus is not considered there. Okay, so we have to apply the reduction formula here. So how will you do that? We have to find out the quadrant, right? So here we have to find out the quadrant. So here you can see that in the second quadrant, sec is negative. In the second quadrant, sec is negative. So here also you can see a negative sign, right? So we can convert this into uh, some angle in the second quadrant. What is the general form of the angle in the second quadrant? It is pi minus theta. It is pi minus theta. So let this be the theta angle. Okay, so how can you write minus sec pi by 3? Minus sec pi by 3, we can write this one as sec of pi minus pi by 3. Okay, so what will be the value of sec of pi minus pi by 3? Since pi minus pi by 3 belongs to the second quadrant, it is negative. Okay, it will be negative. So minus sec. And why did I write sec? This because it is a multiple of pi. Because it is a multiple of pi. All right. So sec of pi minus pi by 3. It is a multiple of pi. That's why I wrote sec itself. Okay. So minus sec. Then what is the theta value? It is pi by 3. Minus sec pi by 3. So minus sec pi by 3 can be written as sec of pi minus pi by 3. Alright. So what is sec of pi minus pi by 3? Sec of pi minus pi by 3. So this one can be written as sec inverse of minus sec pi by 3. Okay, minus sec pi by 3 can be written as sec inverse of sec of pi minus pi by 3. Pi minus pi by 3. Okay, sec inverse of sec of pi minus pi by 3. So if you apply the property sec inverse of sec x is equal to x. Sec inverse of sec x is equal to x. So what will be the value here? Pi minus pi by 3. Pi minus pi by 3. That is equal to 2 pi by 3. That is equal to 2 pi by 3. And now we have to check whether this 2 pi by 3 belongs to the principal value branch of sec inverse. What is the principal value of sec inverse? Principal value branch of sec inverse or the range of sec inverse. It is nothing but sec belongs to the second group, right? Cos, sec and cot. So it is all depending upon 0 and pi. So what will be the value? Closed interval 0 pi minus its midpoint pi by 2 should be removed, minus pi by 2. So can we say 2 pi by 3 belongs to this interval? Yes, definitely. But why? 2 into pi by 3 means 2 into 180 by 3. That is, if you get cancel here, it is 120. And 120 degree definitely belongs to closed interval 0 pi. Isn't it? So our answer is nothing but 2 pi by 3. So what is the principal value of sec inverse of minus 2? It is nothing but 2 pi by 3. All right. Now we are moving on to the third question. These are all part of a similar pattern question, but uh, everything is solved in a different manner. That's why I have taken these type of questions. So here, next also you have to find out the principal value of y. Okay, find the principal value of y equal to cot inverse of minus 1 by root 3. Y equal to cot inverse of minus 1 by root 3. So how will you solve this type question? Again, you have to convert 1 by root 3 into some function of cot, right? Then only you can apply the property cot inverse of cot x is equal to x. So how will you do that? You have to find out which angle will give you 1 by root 3 if you put it in the function cot. Right, cot x is equal to 1 by root 3. What do you mean by cot x equal to 1 by root 3? Think about its reciprocal. Then tan x will be root 3. Which value of x for the function tan will give you root 3? Tan pi by 3, right? Tan pi by 3 is equal to root 3. Tan pi by 3 is root 3. So what about cot pi by 3? Cot pi by 3 will be its reciprocal. Cot pi by 3 is 1 by root 3. So how will you write this cot inverse of minus 1 by root 3? Minus 1 by root 3 can be written as minus cot pi by 3. Okay, minus cot pi by 3. Cot inverse of minus cot pi by 3. Okay. Now we know that cot satisfies the property cot of minus x. Okay. Cot of minus x can be written as minus cot x, and vice versa also. That is, if you are given minus cot x, then you can write it as cot of minus x. That is, you can take the minus inside. Okay. So this will become cot of minus pi by 3. Okay, cot of minus pi by 3. But here what happens is that this minus pi by 3 doesn't belongs to the PVB of cot inverse, right? Does minus pi by 3 belongs to what is the PVB? PVB of cot inverse is nothing but it is open interval 0 pi, right? PVB of cot inverse is nothing but open interval 0 pi, right? So this is minus pi by 3. Clearly minus pi by 3 doesn't belongs to open interval 0 pi, right? So what we have to do is that here instead of using that property, you have to apply the reduction formula in minus cot pi by 3 in order to make it in a positive quantity. All right. So here what we have to do is that we have to apply the reduction formula. That is, how will you convert this minus cot pi by 3? How will you convert this minus cot pi by 3 into a positive quantity? We have to again check the quadrant, right? So which quadrant will give you negative quantity? Negative quantity here you can see that um, in this quadrant it is in the second quadrant. 1 minute. Okay, in the second quadrant we know that cot is negative, right? So we can choose that quadrant. In the second quadrant the general form is pi minus theta, right? So pi minus theta is our general form of that the angles in the second quadrant, right? So minus cot pi by 3 can be written as cot inverse of So first of all, we'll just consider this portion only. That is minus cot pi by 3. Okay. So this we are going to apply the reduction formula. So if I write this one as cot of pi minus pi by 3. Okay. So if I write this like this, cot of pi minus pi by 3, the value will be cot, since this is a second quadrant, the value will be minus, right? Minus cot pi by 3. Minus cot pi by 3. All right. So if I write cot of pi minus pi by 3, then it will become minus cot pi by 3. Okay. So we can rewrite this like this. So how will you rewrite? Cot inverse of minus cot pi by 3. Minus cot pi by 3. So here minus cot pi by 3 is equal to this one. Right. So cot inverse of cot of pi minus pi by 3. Cot inverse of cot of pi minus pi by 3. And if we apply the property cot inverse of cot x is equal to x. So what will be the answer here? Here in the place of x, you can see that it is pi minus pi by 3. So what will be the value? It is nothing but pi minus pi by 3. Pi minus pi by 3. And what is the value of pi minus pi by 3? It is 3 pi minus pi by 3. That is equal to 2 pi by 3. Okay. 2 pi by 3 means 2 pi by 3 means it is 2 into 60. Isn't it? 2 into 60 means 120 degree. It belongs to this is cot inverse, right? Cot inverse means open interval 0 pi. Open interval 0 pi. All right. 120 degree belongs to the PVB. So we can say that 2 pi by 3 is the answer. What is the answer? 2 pi by 3. Okay. Now we are moving on to the next question. That is our fourth question. Find the value of find the value of find the value of tan inverse 1 plus cos inverse of minus 1 by 2 plus sine inverse of minus 1 by 2. We have to find out the value of tan inverse 1 plus cos inverse minus 1 by 2 plus sine inverse minus 1 by 2. How will you find out this? We have to split this into three parts. Okay. We have to split this into three parts and solve them separately, then add the answers. All right. So we'll start with tan inverse 1. We'll start with tan inverse of 1. So in order to apply the property tan inverse of tan x is equal to x, you have to make this one sum in the form of tan x, right? So how will you write 1 in the form of tan x? Which value of x will give you tan x as 1? Tan pi by 4, right? Tan pi by 4 is 1. So you can replace this 1 with tan pi by 4. Tan inverse of 1 can be written as tan pi by 4, right? So if you apply the property tan inverse of tan x is equal to x, this will be, the value will be pi by 4. And what is pi by 4? Pi by 4 means it is 45 degree. So that belongs to, what is the principal value branch of tan inverse? It is nothing but open interval minus pi by 2 comma pi by 2. Open interval minus pi by 2 comma pi by 2. Clearly pi by 4 belongs to the PVB. So the answer is nothing but pi by 4. Now consider the second part. What is the second part? It is cos inverse of minus 1 by 2. Cos inverse of minus 1 by 2. Again, if you have to apply the property cos inverse of cos x is equal to x, we have to change this 1 by 2 into cos, some function of x, some function of cos, right? So how will you write it? Cos x is equal to 1 by 2. Which value of x for the function cos will give you 1 by 2? It is nothing but cos pi by 3. Pi by 3 is equal to 1 by 2. So how can you write this one? You can write this one as cos inverse of minus cos pi by 3. 1 by 2 can be written as cos pi by 3. All right. Again, by applying the property minus cos x, okay, um, sorry, cos does not satisfy that property, right? Cos does not satisfy that property. So apply the we have to apply the reduction formula. So how will you apply the reduction formula? That is, we have to make this one positive. So how will you apply? We know in the second quadrant cos is negative, right? So we can write this one as pi minus pi by 3, right? Pi minus pi by 3. Pi minus theta is the general form of the angles in the second quadrant. And here it is pi by 3. So I have taken theta, instead of theta I have taken it as pi by 3. So this can be written as cos inverse of This minus cos pi by 3 can be written as cos of pi minus pi by 3. Okay, cos of pi minus pi by 3. Since pi minus pi by 3 is an angle in the second quadrant, cos of pi minus pi by 3 is nothing but minus cos pi by 3. Okay, if it was in the fourth quadrant, we know that cos is positive in the fourth quadrant, so it will become just cos pi by 3. But here, since it is in the second quadrant, it will become minus cos pi by 3. So minus cos pi by 3 can be written like this. All right, now we can apply the property cos inverse of cos x is equal to x, right? So this will be pi minus pi by 3. What is pi minus pi by 3? It is nothing but 2 pi by 3. And we know 2 pi by 3 belongs to closed interval 0 pi, right? 2 pi by 3 clearly belongs to closed interval 0 pi, closed interval 0 pi, right? Now we are moving on to the third part, okay? So we'll just take another page. So the third part was sine inverse of minus 1 by 2, all right? Sine inverse of minus 1 by 2. So we have to write this 1 by 2 as some function of sine, right? So how will you write sine x is equal to 1 by 2? Which value of sine will give you 1 by 2? Sine pi by 6, right? Sine 30 degree is 1 by 2. So sine pi by 6 is 1 by 2. So this 1 by 2 can be replaced as sine inverse of minus sine pi by 6. Okay, 1 by 2 can be written as sine pi by 6. So this can be replaced as sine inverse of minus sine pi by 6. Here we don't have to use the reduction formula because sine satisfies the property sine of minus x is equal to minus sine x. Vice versa also. If you are given minus sine x, then that is equal to sine of minus x. Okay, here you have given minus sine x, right? So we can write this one as sine of minus x, sine of minus x, right? So this can be written as sine inverse of, this implies sine inverse of sine of minus pi by 6, sine of minus pi by 6. All right, we can take the minus inside to the angle. Okay, so what will be the value? Sine inverse of sine x is nothing but x, right? The condition is that x should belongs to the range of the sine inverse. We shall see whether this pi minus pi by 6 belongs to the range. What is the PVB? What is the PVB? PVB of sine inverse is nothing but closed interval minus pi by 2 comma pi by 2. This means it varies between minus 90 and 90. The value here is minus 30, right? So clearly minus 30 belongs to this interval. So minus pi by 6 belongs to this interval, right? So now we have got the three values. That is, we have got the value of tan inverse 1, cos inverse of minus 1 by 2, and sin inverse of minus 1 by 2. We have to find out the sum of these values, right? That was our question. So how will you do that? This was our question. So this is our question. So we have to add all those values. Okay, we have to add all the values now obtained. What were the values? We got pi by 4, then we got 2 pi by 3, and the last one was minus pi by 6. Okay, it is pi by 4 plus 2 pi by 3 minus pi by 6. So how will you solve this? We can take the LCM of 4, 3, 6 as 12, right? So in order to make this 12, we have to multiply it with 3. So in the numerator also, we have to multiply it with 3. So this will become 3 pi plus 3 into 4 will give you 12. So similarly, you have to multiply the numerator also. So 2 into 4 will give you 8 pi minus 2 pi. All right. So the answer is equal to, it is 11 pi minus 12, 2 pi. That is equal to 9 pi by 12. What is 9 pi by 12? If you cut short, it will become 3 pi by 4. 3 pi by 4. All right. We have got the answer for that particular question. Now we are moving on to fifth question. All right. The fifth question is find sine of pi by 3 minus sine inverse of minus root 3 by 2. Sine of pi by 3 minus Okay. Find sine of pi by 3 minus sine inverse of minus root 3 by 2. Here we know that we should always start from within the bracket, right? So from solving within the bracket. So you should start from inside the bracket. That is, you first of all you have to find out the value of sine inverse of minus root 3 by 2, right? So how will you find out sine inverse of minus root 3 by 2? Again, you have to write this root 3 by 2 in some form of sin x, right? So you have to find out which value of x will give you root 3 by 2. Okay, sin x is equal to root 3 by 2. Which value will give you sin pi by 3, right? Sin 60 is root 3 by 2. So you can replace this minus root 3 by 2 as minus sin pi by 3. Okay, minus sin pi by 3. Again, you can take the value inside, right? We can apply the property minus sin x is equal to sine of minus x. So this can be written as sine inverse of this minus sine pi by 3 can be written as sine of minus pi by 3. All right, sine of minus pi by 3. And what happens to this one? Sine inverse of sine x is equal to x. So this will become minus pi by 3. And that belongs to our PVB, right? Pi by 2 comma pi by 2. So the answer is minus pi by 3. Now we have got this portion. Now just substitute in the question. So how will you do that? On substituting in the question, we'll get sine of pi by 3. Instead of sine inverse of minus root 3 by 2, I'm going to write it as minus. Already there was a minus in the question. Now we have got the answer as minus pi by 3. So there comes 2 pi by 3, right? Sine of pi by 3 minus minus pi by 3. So this will become sine of 2 pi by 3, right? So pi by 3 minus minus will become plus, right? So it will become sine of 2 pi by 3. And what is the value of sine of 2 pi by 3? 2 pi by 3 means 2 into 60, that is 120 degree. 120 degree doesn't belongs to this one, right? So how will you convert this one? Sine, we don't know, sorry, sine 2 pi by 3 means we don't know the standard value of 2 pi by 3, sine 120 degree. Okay, so we have to convert this into some standard form, then we will get the answer, right? So how will you find out the equivalent angle of 2 pi by 3? Sine of 2 pi by 3. So again, if you apply the reduction formula, we can write this 2 pi by 3 as sine of pi minus pi by 3. Sine of pi minus pi by 3. How I can write it like this? Again, we have already explained it. That is, in the second quadrant, sine is positive. In the second quadrant, sine is positive. So we can write this as pi minus theta. Angle can be, the general form is some pi minus theta. So I have taken as theta as pi by 3. So I can write this one as sine of pi minus pi by 3. So that is equal to sine pi by 3. Okay, sine pi by 3. Okay. So sine pi by 3 means, what is the value of sine pi by 3? Sine pi by 3 means sine 60 degree. Sine 60 degree is equal to root 3 by 2. Sine 60 degree is equal to root 3 by 2. All right. Now we are moving on to the sixth question. Evaluate, evaluate, evaluate cos inverse of sine pi by 9. Evaluate cos inverse of sine pi by 9. So how will you do this? If you have to apply the property cos inverse of cos x, this should be some form of cos, right? But here you can see that within the bracket it is a sine function. So you can directly apply the property cos inverse of cos x. So we have to apply the reduction formula so that you can make the sine into cos. How will you do that? If I take a multiple of pi by 2, if I take a multiple of pi by 2, then you know that the co-function will come. So these are all properties from the chapter trigonometric function. All right. So in order to make the sine as cos, that means the co-function of sine is cos. Okay, the co-function, it is not reciprocal. The co-function of sine is cos. So we have to make the value inside the bracket as cos. So that means we have to convert the sine into cos. Sine to its co-function cos. So how will you do that? You have to choose the multiple of pi by 2. right? You have to choose a multiple of pi by 2. That is cos of pi by 2 minus some theta. Okay, cos of pi by 2 minus some theta will give you sine theta. The answer is sine theta. Okay, cos of pi by 2 minus theta is nothing but sine theta. Okay, so with the help of this also we can explain the first quadrant. If pi by 2 minus pi by 2 means this one, right? Pi by 2 minus theta means it will go here to the first quadrant, right? First quadrant everything is positive. So which means cos is also positive. So the resultant value is also positive. So sine theta, positive sine theta. And how come sine came here? Because it is pi by 2. It is pi by 2. If we are taking pi by 2, then the answer will be the co-function of the function given here. The function given here is cos, so it will become sine. All right. Similarly, sine pi by 9 can be written as cos inverse of cos of pi by 2 minus theta. Theta is pi by 9. I'm going to take it as pi by 9. Okay. I'm going to take theta as pi by 9. Cos inverse of pi by 2 minus pi by 9. So that is equal to pi by 2 minus pi by 9. Pi by 2 minus pi by 9. Right? So what is the value here? Pi by 2 minus pi by 9. 9 pi minus 2 pi. Isn't it? So the answer is equal to 9 pi minus 2 pi by 18. So that is equal to 7 pi by 18. What is the value here? 7 into 180 by 18. So here you can cancel it with 10. So that is equal to 70 degree. And the 70 degree belongs to the principal value branch. That is nothing but closed interval 0 pi. The principal value branch of cos inverse is 0 pi. And we know 70 degree belongs to closed interval 0 pi. So the answer is nothing but 7 pi by 80. Okay. So these type of questions can also be asked. That is within the bracket you may get a different function. That is different from the bracket, the function outside the bracket. So what we have to do is that we have to change that function into some that is you have to change it into some its co-function. That is we have to apply the reduction formula and change it into some multiple of pi by 2. Okay, then only the co-function will come. Okay, we have to change it the angle into some multiple of pi by 2 minus theta, then only the co-function will come. All right, so this was another type of question from that pattern. Now we are moving on to another type, that is express tan inverse of 1 by root of x square minus 1. Okay, express tan inverse of 1 by root of x square minus 1, where modulus of x is greater than 1 in the simplest form. Okay, so tan inverse of 1 by root of x square minus 1, we have to reduce it into its simplest form. So how will you do that? We have to definitely give some substitution for x, right? So we know that these type of questions can be solved by applying the property tan inverse of tan x is equal to x. You have to study only one property from this chapter. All the other properties are deleted. So mainly you have to convert these type of questions into that property only. That is tan inverse of tan x is equal to x, which means the value inside the bracket is 1 by root of x square minus 1, right? The value inside the bracket is 1 by root of x square minus 1. This should be converted into tan x, right? Then only we can apply the property. So how can I make this value as tan x? If I have to make this value of tan x, I have to make the denominator as cot x, right? 1 by cot x is tan x. Isn't it? 1 by cot x is tan x. So I have to make this denominator as cot x. So I have to think in such a way that how which value of x will make the denominator as cot x? Which value if I put as x, then give you the denominator as cot x. So let's see. If I put cosec x, what happens? If I put x as cosec theta, if I put x as cosec theta, what happens here? You can see that 1 by root of x square minus 1. Okay, that will become 1 by root of cosec square theta minus 1. What is cosec square theta minus 1? Cot square theta. Because we have studied an identity, 1 plus cot square theta is equal to cosec square theta. 1 plus cot square theta is equal to cosec square theta. So from this you get that cosec square theta minus 1 will give you cot square theta. Okay, so cosec square theta minus 1 will give you cot square theta. 1 by root of cot square theta. What is root cot square theta? It is cot theta, right? So this will become 1 by cot theta. And what is 1 by cot theta? Nothing but tan theta. Okay. So the value inside the bracket now became tan theta. Isn't it? So here we know that if I put x equal to cosec theta, I'm erasing this. Now here we have another part, right? Outside the bracket there was tan inverse. So okay, so outside the bracket was tan inverse, right? So this will become tan inverse of 1 by root of x square minus 1. Okay, so that is equal to tan inverse of 1 by root of cosec square theta minus 1. So that is equal to tan inverse of 1 by root of cot square theta. So that can be written as tan inverse of 1 by cot theta. So this is equal to nothing but tan inverse of tan theta. Tan inverse of tan theta, we know the property. Tan inverse of tan theta is equal to theta. Right? Tan inverse of tan theta is nothing but theta. Right? And what was theta? We put x is equal to cosec theta. X is equal to cosec theta. From this you get theta is equal to cosec inverse x. Theta is equal to cosec inverse x. We started from there, right? So we have to replace this theta in terms of x because the question is in terms of x. So the answer should also be as a function of x itself. So this theta should be replaced with a function of x. What is theta? It is nothing but cosec inverse x. It is nothing but cosec inverse x. So what is the simplest form of tan inverse of 1 by root of x square minus 1? It is nothing but cosec inverse x. All right, it is nothing but cosec inverse x. Okay. Now, we are moving on to the next question. All right, we are moving on to the next question. That is, prove that tan inverse root x is equal to 1 by 2 cos inverse of 1 minus x by 1 plus x. X belongs to open interval 0, 1. Okay, we have to prove tan inverse of root x is equal to 1 by 2 cos inverse of 1 minus x by 1 plus x. All right, so here again we know we have to do some type of substitution to solve this type of question, right? So which value should be substituted here? So I'm going to take the tan inverse of root x. Okay, I'm going to take the tan inverse of root x. Tan inverse of, let the tan inverse of root x be theta. So what happens to root x? Root x will become tan theta. Root x will become tan theta. So if I square this one, what happens? This will become root x into root x is x, right? X is equal to tan square theta. On squaring, okay, on squaring, you will get x is equal to tan square theta. Okay, now we have got the substitution value for x. What is it? Tan square theta. Now you have to start from the RHS. What is RHS? RHS is equal to 1 by 2 cos inverse of 1 minus x by 1 plus x. 1 minus x by 1 plus x. Okay, so that is equal to 1 by 2 cos inverse of 1 minus tan square theta by 1 plus tan square theta, because x is equal to tan square theta. So in place of x, you can put tan square theta, right? So this is equal to 1 by 2. What is this? 1 minus tan square theta, 1 plus tan square by 1 plus tan square theta. It is nothing but cos 2 theta, isn't it? So identity. Okay, you have to study the identity in order to solve these type of problems. So 1 minus tan square theta by 1 plus tan square theta is nothing but cos 2 theta. Okay, now we can apply the property cos inverse of cos x is equal to x. So cos inverse of cos 2 theta will be 2 theta. 1 by 2 is already here. Here we are going to apply the property. So that will become 2 theta. And this 2 and 2 gets cancelled. So the answer will be theta. So we can't stop here in theta because the question is in a function of x. So we have to convert this into x itself. So theta is equal to tan inverse of root x. Theta is equal to tan inverse of root x. So this is the answer. Theta is tan inverse of root x. Okay. Now we are moving on to the next question. Prove that 3 cos inverse x, 3 cos inverse x is equal to cos inverse of 4x cube minus 3x, where x belongs to closed interval minus 1 by 2 comma 1. Okay, we have to prove this thing, that is 3 cos inverse x equal to. So I'm going to put x is equal to cos theta. Okay, so x equal to cos theta means theta is equal to cos inverse x. Theta is equal to cos inverse x. Okay, so here if I start from RHS, okay, if I start from RHS, that is cos inverse of 4x cube minus 3x, 4x cube minus 3x, that is equal to cos inverse of 4 into what is x? X is cos theta. So that is equal to 4 cos cube theta. X cube is there, right? So it will become 4 cos cube theta minus 3 cos theta, minus 3 cos theta. All right. So what is 4 cos cube theta minus 3 cos theta? Cos 3 theta, right? So cos inverse of cos 3 theta. Cos inverse of cos 3 theta. That is equal to 3 theta. And what is this theta? 3 into cos inverse x. 3 into cos inverse x. Okay. That was our LHS, right? That was our LHS. So RHS is equal to LHS. So we proved that identity, that is 3 cos inverse x is equal to cos inverse of 4x cube minus 3x. All right. Now we are moving on to the next question. Find the values of tan inverse of 2 cos 2 sine inverse 2 cos 2 sine inverse 1 by 2. We have to find out the value of tan inverse of 2 cos 2 sine inverse 1 by 2. So we should start from here within the bracket. Okay. So first of all, you have to find out what is sine inverse of sine 1 by 2. Sine inverse of 1 by 2. So which value will give you sine x as 1 by 2? Sine pi by 6 is equal to 1 by 2. Sine 30 is 1 by 2. So this can be replaced as sine inverse of sine pi by 6. Okay, that is equal to pi by 6, and this pi by 6 clearly belongs to minus pi by 2 comma pi by 2. The principal value branch. So pi by 6 is the answer. So we'll again go back to the question. Tan inverse of 2 cos into 2 into the sine inverse 1 by 2 can be written as pi by 6. All right. So this will become tan inverse of 2 cos pi by 3. 2 cos pi by 3. And what is this cos pi by 3? Cos pi by 3 is 1 by 2, right? So this will become tan inverse of 2 into cos pi by 3 is 1 by 2. So 2 and 2 gets cancelled. So that is equal to tan inverse of 1. What is this tan inverse of 1? That is equal to pi by 4. Tan inverse of 1 is equal to pi by 4. All right. Now we are moving on to the last question. That is equal to prove that sine of tan inverse x is equal to x by root of 1 plus x square. Okay, prove that prove that sine of tan inverse x is equal to x by root of 1 plus x square, where modulus of x is less than 1. We have to prove sine of tan inverse x is equal to x by root of 1 plus x square. Okay, so here also we have to do some kind of substitution. So what will we give as x for value of x? So we'll here it is, since it is tan function, we'll give x as some tan theta. Okay, I'm going to give x as tan theta. So from this you can say theta is equal to tan inverse x, right? Theta is equal to tan inverse x. Okay, now consider the RHS. Consider RHS. What is RHS? X by root of 1 plus x square. X by root of 1 plus x square. X is nothing but tan theta divided by root of 1 plus tan square theta divided by root of 1 plus tan square theta, isn't it? So that is equal to tan theta divided by 1 plus tan square theta is nothing but, what is 1 plus tan square theta? It is nothing but cosec square. Just a minute. It is sec square theta, right? Yes, sec square theta. Sec square 1 plus tan square theta is sec square theta. 1 plus cos square theta is cosec square theta. Okay, so 1 plus tan square theta is sec square theta. So this will become root of sec square theta. Okay, sec square theta. And what is the root value? Tan theta by sec theta. Tan theta by sec theta. Now we have to solve this part. Okay, we have to solve this part. That is, we have now got it as tan theta by sec theta, right? Now, this tan theta can be written as sine theta by cos theta, and we have a divided by sec theta, divided by sec theta. This can be written as sine theta by cos theta into 1 by sec theta, right? Into 1 by sec theta. Okay, so sine theta divided by cos theta into this 1 by sec theta can be again written as 1 by cos theta. Sec theta can be written as 1 by cos theta because they are reciprocal, right? So this cos theta and this cos theta gets cancelled. So what is the value? That is nothing but sine theta. And what is this theta? We started from x is equal to tan theta. So we know theta is equal to tan inverse x. So instead of this theta, I can put tan inverse x. Sine of tan inverse x. And this was our RHS, right? This was our LHS. Left hand side. We started from RHS. That is, we got it is equal to LHS. So hence the proof. All right. So we have proved that question also. Okay. So that's all for today. I hope this session was useful to you all. In the next session, we'll be discussing the 3 mark questions from this chapter. So until then, thank you. Bye.